Notes 2-8, imaginary numbers. The first thing that you have to accept with imaginary numbers is that in order to deal with these and to write them, we just agree that we're going to, by definition, that when we see the square root of -1, we assume that that's defined as the letter I. So, so you have to start there. So, so let's do some examples where it's just simplify these expressions. So for example, if I have the square root of, I want to start with a perfect square. Sure. The square root of -9. Square root of -9. Okay. So, and I want to simplify that. That's not simplified. The answer is 3i. What you should say is 3i. Let me show you why. Okay. The square root of -9 is, you can break it up into the square root of -1 times the square root of 9. So first, because with operations with radicals, if it's under the radical, you can put it into two separate radicals. So, everyone's taking notes? So then, this, by definition, we agreed was just I, right? By definition, and now we can do the square root of 9. What's that? Yeah. So it's I times 3, but we don't write things in that order. We don't like we want the constant to come before the variable, so 3i is the answer. So that's how you simplify. So let's try one more like that. We can do it faster maybe. The square root of -4 is, what's the answer? 2i. I'll go through the steps though. If you want to write the steps, you can. This is the square root of -1 times the square root of 4. The square root of 4 is 2, and that's defined as I, so the answer is 2i. But it's okay to go straight to the answer. Now, let's look at when we have something that's not maybe a perfect square, like the square root of -5. What do you think the answer would be there? Close. So we would put an I on the outside, and it would basically be I root 5. So you can't, the square root of 5, let me show you why. Because it's the square root of -1 times the square root of 5, right? Just like before. The square root of -1 is defined as I, but the square root of 5, we can't do that unless we want a decimal approximation, which we wouldn't. So it's just, the answer is just I root 5 is the answer. These are the answers. So if it's not a perfect square, you can still simplify it. You basically think of it as getting rid of the negative under the radical by putting an I in front. That's basically what it is. And if it is a perfect square, you can simplify it. If it's not, you have to leave it under the radical. So now let's try two complete examples of solving quadratic equations. Let's bring it back to what we've been studying. So we'll do two examples. Example 1. Let's say I want to, this is what you'll be doing in your homework, mostly. So 6x squared plus 5 equals 2x squared plus 1. We want to just solve for x. So you get all the like terms on the same side. We get all the x squareds together. So subtract 2x squared from each side. So you get 4x squared plus 5 equals 1. This is just like solving any quadratic equation. And then subtract 5 from each side. We want to get the x squared by itself. Divide by 4, and this is where it's not what you're used to, because you have a -1 and it looks like you can't answer that. Well, you can't give any real solutions, but you can still give an imaginary one. So the final answer is, when you take the square root, just like you're used to, it'd be plus or minus the square root of -1. And that would just be plus or minus I. because square root of negative 1 is defined as I. Exactly. Yeah. So let's try another one. Let's try 3x squared minus 7 equals negative 31. So you would just add 7 to each side. And then what? Divide both sides by 3. And then of course take the square root. So plus or minus the square root of negative 8. Okay, so this one, you can write I root 8 to start. So we don't have the negative under the radical anymore. Just put an I in front. But the square root of 8 does simplify, right? What perfect square is in 8? What times what gives you 8? 2 times 4, right? And 4 is a perfect square, so I'll do it one step at a time. Square root of 8 is the square root of 4 times the square root of 2. Right? Square root of 8 is square root of 4 times square root of 2. Square root of 4 is a perfect square, which is 2. So that changes to a 2, so you get plus or minus 2I root 2. That's your final answer. Yep. Two imaginary solutions. I need to show you one other thing that'll be really nice and easy. That's distributive property and combining like terms. Yeah. Yep. Do you always want a fraction? A radical? No. Only if there's something that you can't take the square root of, then. Oh, no, yeah, never decimals. No. Yeah, always leave these as radical answers. Exactly. Yeah. That's okay. And then the last example is you're going to see things that in the second set that just say simplify. So this should be really easy and it's a nice review. 3 plus, let's just say 3 plus 7i and minus 8 minus 2i. This is just working with expressions. And the I works just like an X, like when combining like terms or using the distributive property. So let me show you how easy this is. So you would just do 3 plus 7i and then minus 8, right? You distribute a negative. When you see parentheses, it works all the same way you're used to. So it's minus 8 and then what? Plus 2i. So no more parentheses, right? And now I just combine like terms. 3 and negative 8, negative 5, and 7i plus 2i is 9i. And that's it. This is just FYI, this is called a complex number. It has a real part and an imaginary part, but you won't need to know that. And you just leave your answer like that.